Wow, what can I say about the temperatures? The temperatures have been warmer than normal since last August. This is just 6 months worth that I've got displayed here. Amazingly long period of time of warm weather. And certainly a question that may be on the tip of everyone's tongues here is, well, is this global warming? Is this what we're going to experience from now on? Those kind of questions. The answer is no. There's a very good reason for why we had all the heat this year. It's something that is somewhat complex. There's two good reasons for it. The first is something called Arctic oscillation. It has to do with how much high pressure is present in the Arctic. The in the Arctic, there's normally a high pressure system present all the time. The high pressure system varies in intensity, and when it's very strong, it forces cold air that's in the mid-levels of the atmosphere down to the surface. And during the winter time, once that cold air is pushed to the surface, it has to go somewhere. And since we live on a planet that's a sphere, basically, the cold air is spread out to the lower latitudes as more cold air comes down from the upper levels of the atmosphere. So if you can picture that in your mind, in a normal winter, we get a lot of cool air that way. And when the high pressure system is very strong, it produces a lot of cold air and makes everybody colder than usual. When the system is very weak, as it was this year, it does just the opposite. A lot less downward movement of cold air occurs in the atmosphere, and therefore the Arctic doesn't get as cold. And if the Arctic isn't cold, then obviously the mid-latitudes will also have a tendency to be warmer as well. So the initial reason for all this was this high pressure system in the Arctic. We call this particular phase when the Arctic high pressure system is weaker than normal. We call that the positive phase of Arctic oscillation. And in those situations, we almost always will have a warm winter. In the opposite, of course, we get colder than normal winters when that high pressure system is stronger than normal. Now that got us all the way from October through the first week in January. And in the first week in January, things kind of changed for a little bit. The Arctic oscillator backed off, went actually back to neutral, in fact turned slightly negative for a little while. And if you recall, part of the prairies got very cold for a brief period of time. And for that first week in January, I happened to have been up in the Saskatoon area at the time, and it was 31 degrees below zero at that point. It was the coldest day or coldest week of the season, really, across a big part of the region. Right after that, a big change took place in the atmosphere in which the high pressure system in the Arctic was suddenly relocated to Russia. Something like that doesn't happen very often, but every once in a while we'll see that high pressure system get forced into some lower latitude location, and it hangs out there for a number of weeks. And that's exactly what happened in late January and February. And because the high pressure system shifted over there, it forced all the cold air over there as well. And on this side of the planet, we enjoyed more warm weather. And so between the Arctic oscillator and this relocation of the surface high pressure system, we ended up with an unusually warm winter. The odds of this happening again anytime soon are very low. So be prepared for colder weather in the next winter season. Phenomenon. This is an 18-year cycle we're going to talk about now. Okay, we've talked about ocean temperatures and El Nino La Nina. We've talked about Arctic oscillation. Now I'm going to talk about the 18-year cycle. All of this is going to be brought together when I present this forecast to you here in just a few minutes. So I want to make sure everyone understands where I'm coming from when I come up with the forecast, so you can see why I'm wrong when the time comes. The 18-year cycle has to do with weather patterns high into the atmosphere. If you're familiar with the term jet stream, the upper level high river of winds that are concentrated that occur in the upper atmosphere are basically what controls where storms move. The jet stream sometimes can be orientated to bring systems out of the northwest part of Canada down through the heart of the prairies and into the States. Sometimes it'll come in from the U.S. Pacific Northwest and move straight eastward across the southern prairies and northern U.S. plains. Sometimes it'll come in from the the Great Basin in the U.S., the central U.S. Rocky Mountain region, and then curve all of a sudden rather dramatically to the north, coming up through Saskatchewan and Alberta. It can do all kinds of things. So, but what we found over the years is that the 18-year cycle dictates where this storm track is going to be. And what we found is that if you take a look at the 18-year cycle and concentrate on it, you can find general trends that are in place that occur over and over and over again. And in this particular year, we're looking at some analog years here that go back to 1940, 1958, 1976, and 1994. These are all part of the 18-year cycle years. And I took the data from each one of those years and I averaged it together. I wanted to see how the 18-year cycle had a tendency to produce precipitation biases and temperature biases in the prairies. So what you're looking at is percentage of normal precipitation that occurs during the spring season across the prairies. Everything that's blue on this chart is basically going to be an above average precipitation bias. Everything that's got a tinge of green or yellow, kind of yellow-green, you're going to find that is below average precipitation. And of course, the brown areas are more significantly below average, as the chart here shows. And just to let your eyes wander across the screen real quick and look at March, April, and May precipitation, and you'll notice that one thing that's missing is a lot of blue. There's not a lot of blue. In the month of March, Alberta tended to be wetter than normal, but you get outside of the prairies, which is in the northern part of these graphs, and you see some wet weather up there. But the heart of the prairies themselves tend to run a little bit lighter on precip. In March, it tends to be 75 to 100% of normal. In April, there's a lot of this yellow-green and light-green area. Well, the yellow-green is 50 to 75% normal, and the green is a little bit better than that. And then when we get into May, there's a tendency for even less precipitation to occur in the southwestern prairies. Again, this is an average of these 18-year cycle years. It is not necessarily suggesting that every one of the years was laid out this exact same way. But it's interesting to note that there's not a lot of abundant precipitation except in parts of Alberta during the spring season, and Alberta tends to be wetter early on. Well, think back for a moment on the weather that's occurred over the past 2 or 3 weeks, and you may very quickly come to the conclusion that Alberta has been wetter than these other areas across the prairies. Very interesting to see how the parallels work here. Well, let's take a look at temperatures for the spring season. Well, look here. Most of the blue color now is below average temperatures. And what this is saying is the 18-year cycles tend to support a cooler bias across the region rather than a warmer bias. In fact, the warmer bias is a yellow color, and you'll notice there is no yellow color on these charts. So if we average these years that I mentioned before together, we come up with no warmer than normal bias, which I find very interesting because if you go back in statistics and look at all of the years in which we had many months of warmer than usual weather like we had here this year, I mentioned earlier that we've had 8 months of warmer than normal conditions. If you go back in time and look to see what happens after you've had that kind of prolonged period of warmth, you almost always come up with a cooler bias, or at least less warmth. And so this particular 18-year cycle is reinforcing the statistical evidence that we will see less heat over the course of the summer. We will not continue the warmer than usual biases that we've been seeing. All right, in the summer, the same set of charts here. This is June, July, and August. We're talking about percentage of normal precipitation. Again, notice there's not too much blue on here, but there is a little bit. June was kind of moist, a little bit less so in July, and even less so in August. But this chart really doesn't suggest there's a lot of big issues here across the prairies, unless, of course, you have a dry bias to begin with, and then you might be a little bit concerned. Well, we do have a little bit of a dry bias out there to start with. Well, what about temperatures in the summer? Well, here we are again, more evidence of cooler than usual conditions suggested in the 18-year cycle. So we're going to keep this all in the back of our minds and add this in as more fuel for our summer outlook. You probably have a pretty good idea where I'm going with our forecast at this point in time. Let's take a look at one of the analog years that stood out as being very similar to this year. This is 1976. 1976 was one of the 18-year cycle years. It is also a year where we lost La Nina and went in towards an El Nino, very similar to this year. there are a number of other patterns that are very similar between these 2 years. Notice real quickly, and I'm going to run through this fairly quick, that the precipitation pattern wasn't all that terribly bad in 1976. In the month of March, we had quite a bit of precipitation occurred across the Midwest. Well, we didn't do that this year, but just stay with me for a moment. In April, there tended to be a little less precipitation, especially in the north and the western part of the region, and a little bit still above average in parts of the southeast. When we went into May, we ran into some dryness across especially the southeastern part of the prairies, but even in the southwest there was some of that. And then in June it was wetter again, and then we were drier again, and then we were drier still in some of the middle areas. But if you step back and look at the big picture, you're probably noticing a good mix. We were dry for a while, we got some rain for a while, we got dry again, and more rain. And so it really turned out to be a fairly decent year. And if you go back and look at your personal records, you might be able to determine that 1976 wasn't a bad year for the majority of the prairies. Now, not every one of these years will always repeat itself, and I urge a lot of caution here, because I don't think we'll have exactly a perfect year like we had in 1976. It wasn't perfect for everybody, but it was at least a year of mixed weather. Move into the late spring, we're likely to see generally a favorable environment for farming. There will still be a dry bias in the south, so keep an eye on that. These areas will probably have a little bit tougher time getting moisture to come into the region in a significant manner. Again, I don't want to imply that there is not going to be any precipitation, but the quantity of moisture that we get is going to be below average in the southern parts of the prairies. There will also be dryness issues still going on in the northwest part of Saskatchewan and northeastern portions of Alberta, and notice we also developed some dryness in the Peace River region. This does not strike me as being terribly bad environment. For the majority of the prairies, I think it's pretty darn good. We will have to deal with moisture management in the south. Be really careful not to wait for the perfect storm to come along and bring us enough moisture that we're going to sit pretty for a long time. Take advantage of the moisture when you've got it, and we'll still manage to get some moisture to come across these southern areas, but it is going to be a little lighter than normal at times. I do think that we may see a nice little period of rain next week across some of these drier areas in the south, and that may actually bring us into a favorable environment for getting some field work done, but be careful not to get too far ahead of yourself, because we do still have that cooler bias that's going to be playing out in the eastern part of the prairies. But we are expecting to see at least a little bit temporary improvement in soil moisture across the southern part of Saskatchewan. As far as the northern part of the prairies or northwestern areas, be careful up here, because I'm not sure we're going to see a tremendous amount of precipitation for a while. If we keep that cooler bias of air present in the eastern prairies, it's all going to have its source up in this region, and it's going to move from the northern part of Alberta into the southeastern part of the prairies. And in that kind of a flow pattern, we don't get a lot of precipitation to fall in this particular region. And that's why I think we're going to have to fight dryness for a while longer in this particular region. And this will be probably the last area that's going to get relief from the drier biases present today. In the summer, the very first thing to notice is that the precipitation charts are on the bottom here. The temperatures are on the top. As far as precipitation is concerned, it looks pretty darn good. In fact, it might be a little bit wet in part of Saskatchewan. But both early and late summer do quite well with moisture, with the exception, again, of the far southeast, where there will still be a little bit of a bias for dryness, both in the early and the late summer, with the late summer probably being a little bit more significant. So the implication here is that if you're in southeastern Saskatchewan or even south central Saskatchewan, opportunity for rain that will come. It's not going to be very frequent. We will have a below average precipitation bias, but without the temperatures early in summer are really not terribly warm. You know what? I just now noticed this chart's mislabeled. I'm terribly sorry. This top chart should be the early summer temperature outlook, not the rainfall. So this should be temperatures. These are below average temperatures in this region. I'm terribly sorry about this. But like this chart, this is the temperature anomalies. And the point here that I wanted to make was that it will be warmer than normal later in the summer in the south central parts of the prairies. Let's see. the the summer conditions in general, obviously here we end up with a pretty favorable moisture situation in the middle of the region. There will also be a tendency for drier biases in the southeastern part of the prairies. Um, the environment still is generating some below average bias in the upper parts of the region. The you know, we'll put a little bit more moisture back into the pipeline here before the growing season's over. So we want to kind of avoid El Nino if we can. I don't think El Nino will be with us, at least not in full strength, so its influence will probably be fairly meager. The overall bottom line, I think, for the planting season for the prairies is this. It's obviously plenty moist right now across Alberta. Many areas in portions of southwestern Alberta and central Alberta are too wet and will probably continue to be that way for a while longer. And with the temperature bias being what it is and the precipitation bias being what it is, there may be an issue with getting some field work done in those particular areas. There is also going to be a tendency for the dry bias in the heart of Saskatchewan and southwestern areas to turn just the opposite as we move into the summer season. So if you're concerned about moisture, be aware that we will tilt the other out in the fields. You may run into a little more frequency on precipitation. And in the southeast corner of the region, that drier bias may hang with us for a bit. As far as the summer threat of severe weather is concerned, I do think that there is a risk of severe thunderstorms in the south central parts of the prairies, and this is going to have a lot to do with the position of the high pressure ridge that I mentioned before that will build up in the U.S. plains. I'm going to talk about this in just a little bit more detail here in a moment. I'm noticing a question here regarding the east central parts of Saskatchewan, where there was a lot of very heavy snowfall and moisture here recently. So some of that area, the comment here that was brought to me was that we need a lot of wind in order to dry that out, and that's exactly correct. We need wind and we need some warmer conditions. I think for the east central sections of Saskatchewan and neighboring areas of Manitoba that did get hit with that big storm here not too long ago are going to see gradual improvement take place, but it will be a slow process. We aren't going to just see a lot of warmth, but we will see a lot of wind periodically. The wind is something we've had a lot of this winter. We're going to see more of that. Let me jump you down into the states as we move forward in time. This ridge of high pressure may not be in the exact right location, but it's pretty close. The question is will it be this intense, or will it be more intense, or will it be less intense? This actually is an illustration of a weak ridge of high pressure. It suggests that there will be drier than usual conditions in the U.S., but with the ridge being not quite all the way into Canada, it means that storm systems will move along this line and move up into Canada. And this is the reason why Canada's prairies end up with a lot of precipitation in Saskatchewan and southern Alberta, because storm after storm will come up along this jet stream route and bring rains up into this area before turning back southward into the U.S. eastern and northern parts of the Midwest. The stronger this ridge is, the more further north the precipitation in Canada will go. The weaker the ridge is, the more likely rain will fall in the southern parts of the prairies. So it's very important where this ridge is going to be. And we are confident that in July and August, this ridge will be present, and it should start to develop in June. In the later part of summer, the ridge is given a little bit more amplitude, and it will turn a little drier than in southern Saskatchewan and southern parts of Manitoba as this takes place. And that's the whole reason why the forecast for the summer is what it is. Now, for those of you concerned about hail potentials for the summer, notice the position of this top of the ridge. This is where the atmosphere is almost always most unstable during a severe weather would be the area that would be most vulnerable to severe thunderstorms and hail and tornadoes and all that good stuff. So again, the amplitude of the ridge is going to determine where the severe weather will be. But with the way it is setting up, the greatest risk of severe thunderstorms is probably going to be in southern Saskatchewan. And we'll need to just keep an eye on, I don't know if your local weather there will be able to give you the position of the jet stream from one day to the next, but we'll keep an eye on it. If you do get that privilege, when the ridge is up into the heart of Canada's prairies like this, you can expect to see some kind of severe weather. I know that India competes with most of the prairies on a lot of fronts. We have the lentil crop, we have wheat, we have rapeseed, we have mustard, we've got sorghum, and all of these crops are produced twice a year in India. The winter crop is being harvested now. It's maturing and being harvested. And I'm showing you the chart here to just show you the fact that most of the main production area had plenty of moisture during the most important time when the crops were reproducing. The only area that did not do well with precipitation is in this particular area of India, northwest India, where there are a number of crops that are produced. This chart down here will show you where most of the wheat is produced. All the green color is where the wheat is produced. The red outlined area is where the durum wheat is. The blue numbers represent the lentil production areas and the percentage of those areas relative to the nation's total. And you'll notice that about almost 40% of the lentil crop is produced in Rajasthan, and that is the area that's been rather dry. Now, before you get ahead of me, they irrigate a lot of this land, but some of it they don't, and some of the yields are down. Both rapeseed and lentil production or yields are probably going to be low. India's monsoon is expected to get underway at the 1st of June. The monsoon in India is largely controlled by ENSO. And if we have an El Nino form, which I've already said that probably won't happen, at least not very quick, but if it does happen, India will get very dry, to the point of threatening some of the crops. And so we'll need to watch that, especially if NOAA's forecast for an El Nino by July is correct. The dryness in India will be a very significant factor, and it will control markets around the world. Now, that is not my forecast. This chart will be updated actually next week. And what I'm going to do to this chart is I'm going to reduce precipitation in northern parts of India. The reason why I'm going to do that is because it'll rain heavily in eastern parts of India, not so much in the west. And the bottom line is that India will do okay with their crops in general, but there will be a drier bias unless El Nino kicks in. And some of those northern areas may have a little low water supply situation going into next autumn. In North Africa, the Durham area, a big part of South Australia, portions of western Victoria, even southeastern Queensland. But today is only the second day in the planting season, and their planting season goes through June. And I believe that the second half of April through June will be wetter than normal across southern Australia, providing a much better environment. It develops, it'll be even drier still, so we'll keep an eye on that. Last stop here is going to be China. China has no problems with their wheat at this moment in time. Their rapeseed's looking very good, and it's a question as to what happens to the dryness that's present in northeastern portions of China. This area, in this region up here, of the spring wheat and sugar beet areas definitely need to see an improvement in soil moisture. That is what we'll be watching in China. I don't expect any trouble from the rest of the country through a big part of the growing season. This area, though, I do think